Yeah, I would like to thank all of you to come here on a Saturday for the meetup. I am Abhishek. As Michael mentioned, I'm part of Nokia. So I started my career in 2004. I worked on multiple telecom products within Lucent and then Alcatel-Lucent and eventually Nokia till 2016. So from 2016 till now, I am part of this platform team where we deal with multiple open source components. And in this team, I'm a product security lead. So I deal with security issues with open source components, multiple security initiatives within this team. So for the last 10 years, I've been doing this. So today I'm going to talk about how we deal with open source vulnerabilities, what are the challenges we face, and how we have used the AI agents to mitigate some of these problems. So what are we going to cover in the next 30 minutes? First, we'll discuss about the problem that we have, why the reports that scanners generate aren't good enough. Then we'll talk about the advantages we get with AI agents, the difference between normal LLM prompt versus AI agent. And then we talk a little bit about the framework that we have used to build these agents. Then we'll talk about the actual product security lead agent, which we are using for doing the CV assessment. What are the inputs we give to the agent, how the agent generates the analysis, what are the evidences it produces. And then we'll talk about a couple of sample assessments from the real world CVs or vulnerabilities. And then we have one slide about the roadmap for this agent. Okay, so quickly getting into the problem. So generally what happens when we run scans for identifying vulnerabilities, we have multiple open source tools to generate scan reports, right? They generate hundreds of vulnerabilities whenever we run the scan. One of the study which has been done from the vulnerabilities reported in 2004, we have seen almost 29,000 to 30,000 vulnerabilities on the open source components, right? And this is bound to increase with the advent of AI and Mythos and things like that. Now, what is the problem with this? In many cases, we have seen the vulnerabilities reported by these tools, they may not be exploitable in the context which we are deploying or in the model that we are deploying, right? Scanners are just kind of inventories. It looks into the databases, it finds a package, okay, these are the vulnerabilities in this package version, it reports. It may or may not be applicable for the deployment that we are making for our product, right? So whenever these scan tools reports the vulnerabilities, it's the responsibility of security engineer to figure out whether it is exploitable, whether it's applicable for me, and come up with a disposition, right? When the count of vulnerability is huge, the amount of effort that an engineer has to spend in doing this kind of assessment it grows, right? And another big problem is this kind of thing is not scalable. Like if there are, let's say, hundreds of vulnerabilities, we cannot have all the team looking into the vulnerabilities and providing a mitigation, because as many of us know, this requires experience. You should have knowledge about how the vulnerabilities can be exploited. So it's not easy to tell that, okay, my whole team is involved in doing the assessment. That will not work, right? So this is the high level problem that we have with dealing with open source vulnerabilities. Okay, so why AI agents, right? We have multiple LLM models, we have prompts. What are the problems, or what are the difference between doing an assessment using a prompt versus using an AI agent, right? So with a generic AI prompt, let's say you have a ChatGPT or any model, right? So that will not have any knowledge about your code base or your deployment model, right? And we have seen cases where for a same vulnerability or a same CV, if I generate the report or generate the assessment multiple times, every time there are chances that it may give a different assessment, right? So there is no persistence, or there is no similarity, right? And we have also seen cases where model hallucinates, and the assessment that it generates we will have a very high confidence even when the actual assessment is not right. Right, so this is another problem that we have. And if your organization, you are expecting an assessment in a particular fashion, or you want it in a particular format, it is very difficult to get this output from an LLM prompt, right? So we are trying to solve all these problems with an agent. So what do we do with agent? We feed in my product or any product information for which we want to do an assessment. Right, we'll look into further details on what we feed into the agent. Another thing which agent will have is it will have a persistent memory. So if you have a particular kind of particular pattern of assessment, you can store it in the agent, so that in future, if a similar vulnerability is reported, the agent will get the information from the persistent memory and then give you a report in a expected format. And then you can also feed in your decision tree or your disposition guidelines. Let's say if conditions A, B, C are met, vulnerability is mitigated. Or if A and B is met but not C, it is false positive. So you can feed in this kind of decision tree or guidelines into this agent. And again, you can ask the agent to generate output in a particular fashion, which you can use if you have some downstream tools, or you want to store it somewhere within your organization. You can get the report in a required format, right? And the most important thing, you can share this agent with different teams, or within team, if different members want to do the assessment, you can share this agent with multiple people or multiple team members and expect similar kind of output that is getting generated, right? So these are the advantages. Okay, so how did we build an agent? So we have used open source framework. It's called BMAD. It's it's the GitHub project, or the GitHub link. If you see, it has almost 50,000 stars. And of late, from the last couple of months, there is a lot of traction in this community. We started using it maybe 2-3 months back, and we have used version 6.0 for generating our agent. But in the last couple of months, so many new features has come in. I think as we speak, the latest version is 6.8, right? So a lot of traction, or a lot of people have started using this now to into their work. Okay, so at a very high level, BMAD has a set of agents or a predefined set of personas for common set of activities. Let's say it has agent for doing code review, it has agents for doing a Scrum Master kind of a role, or a product manager kind of a role. It creates tickets for you. For all these predefined roles, it already has the agents. It also has a flexibility to build custom agents. So if you have a custom workflow, you can talk to BMAD, or you can build your own agent by doing this kind of customization. BMAD will help you brainstorm. If you give a problem statement, it will brainstorm with you on what could be the possible workflows, or what options you can include in the agent, right? And the artifacts that it generates, you will see further, all are in either YAML format or a Markdown format. So it's very easily, if you have multiple versions, it's easily reviewable. You can find the difference between old and new versions. You can share it very easily within your team. Yeah, and we are currently using it with Cursor. But there are options, to integrate with other common ID platforms like Windsurf or GitHub Copilot. And there are multiple options. Once you start exploring, you will figure out that. I have also shared the link here in case if you want to refer. So how does an agent look like, or what are the basic fundamentals of the agent? So every BMAD agent will have a persona. So that will define what that agent is, what is its role, how it should interact with the user, what are the principles it should follow. So it will have this kind of persona defined. There will be a set of capabilities which defines what are the inputs that will be passed to the agent, how it should read the input, and what kind of output it should generate. And of course, as I mentioned, there is a sidecar which has the capability to store information for future references. So I can store precedents, I can store the analysis that I'm going to do, I can store set of instructions, I can build a knowledge base basically. And then what actions it is supposed to perform. So when an agent starts, what all things it has to load into the memory, how it should, what are the set of steps that it has to follow will be defined in the agent. And also it will have a kind of a menu which will tell what are the options available with the agent or what actions the agent can perform. So even the menu, I'll just show what are the menu that we have in our agent that we have developed. Okay, so here comes the hero. So this is the agent that we have built, which for doing the CV assessment. So we have named it as Garuda. As many of us know, it's a mythological character, and it's known to be a vigilant guardian. So we have named it mainly to safeguard the security posture of our product. So that is the reasoning behind the name. What exactly it does? So given a CV or given a vulnerability, the agent will go through the input that has been fed into the agent, or you can say pre-configured in the agent, and it will figure out whether the vulnerability is exploitable in my product, in my deployment context. Then it does the CVSS score calculation. As many of us know, whenever a vulnerability is reported, community will provide a CVSS score as per the vulnerability. But many of the cases we have seen that CVSS score given by community may not be same for our deployment. It may be less, it may be more. Right, so depending on the deployment context or depending on the exploitability, the CVSS score gets recalculated. And then it decides what is the disposition, whether it's a false positive, whether it's a mitigate, accept, what kind of disposition has to be given for that vulnerability. Depending on the guidelines that has been configured in the agent, it comes up with that disposition. Then another important point is attack scenario calculation, right? So here we want to we want to provide as much information. I mean, because we are from a common platform team which is used by multiple products, we want to make sure we give as much information as possible regarding vulnerabilities, right? So we try to capture this attack scenario where we share the availability impact or the confidentiality impact, or what are the mitigations possible, workarounds possible. So the issue that we have seen when we do manual assessment, this kind of information becomes very inconsistent. Some people give in a particular fashion, some people give in another fashion. So it's very difficult to have a common kind of structure for this kind of attack scenario generation. So with this tool or with this agent, we have instructed or we have given how the attack scenario has to be calculated in what format. So it generates for each CV, it generates attack scenario in that required fashion. And then it also has a capability, if you have a scan report from some, let's say Anchor or Trivi, which reports hundreds of vulnerabilities, you just pass in that report to the agent. Agent will take one CV at a time, do the assessment, and give the report in a CSV format, which you can further use for, in your downstream tools, or you can store it somewhere if needed. And then again, the assessments which the agent generates can be stored for future. I will show you an example where the this precedent really helps in doing the assessment. Okay, what are the capabilities? Again, it's more or less similar to what we discussed earlier, but in terms of a menu. As I mentioned, every BMAT agent has a menu of actions that the tool can perform or the set of operations that the agent can perform. So we'll quickly go through what are the capabilities that Garuda has. So first thing is the product info. This is again a pre-fed information to the agent, and the more information you capture here, or more information you feed to the agent, better the quality of assessment you will get. So when we talk about product info, it's not only about code base, it's also about what is the what are the different deployment models that your product is capable. Let's say you have a Kubernetes deployment, you feed in the pod context, you feed in security context like Madhu sir mentioned, you pass in the ingress details, you pass in the service spec, you feed in as much information as possible to the agent so that it uses all this information for doing the assessment. If you have an RPM deployment, you can pass in, let's say, the netstat output, the ports that are open in your deployment. So this kind of information can be pre-fed into the agent depending on the product's capabilities, right? Then there is a analyze CV option. So here we just pass in one CV, or let's say comma separated list of CVs. It picks each CV, does the calculation of expert score, prepares the disposition rationale, and gives you the output. Again, scan report is an extension of analyze CV, wherein I pass in the report from a scan tool, and it will generate an output in a CSV format. The next two options are mainly related to the memory, the sidecar memory that I was talking about. So we have an option to go through the existing assessments that are stored. In case if you want to modify something, let's say 1 year down the line, if you want to go through some of the assessments and see whether you want to change the way the assessment has been happening. So you can look through these precedents and modify, because all these are in markdown format. It's very easy to modify this as per our requirement. Right, and save analysis. So once the agent does the assessment, there is an option to save into the memory, and then we have an option for configuring the sources. So this is another important point. How does the agent know details about vulnerabilities? Right, we have pre-fed the agent with a set of default sources. I'll share those details as well in subsequent slides, where the agent will go and look for the details of the vulnerability. Once it knows the details, then it comes back to the context and figures out whether it's exploitable or not, right? So there is option, or we have given a default set of sources, but we also provide an option in case if product wants to change the default sources, or if you have a, let's say, some other source which has to be referred. Let's say you have an enterprise product and the enterprise is giving you a good assessment for all the vulnerabilities. You can feed in that source as well and get the information from there. Okay, the next one is about, we discussed about multiple commands in the previous slide, right? So how does each command look like within BMAD? So I have just captured a screenshot of one of the command, which is for analyze CV. So as we can see here, we just tell what has to be done by this command. When this command is invoked, what are the set of actions that has to be performed, right? So when I trigger analyze CV, I'm expecting the agent to load the product info, to prompt for a CV ID to the user, then cross-reference the source software bill of material, and then look at the code, compute the expert CVSS, assign the disposition as per the decision tree, generate the attack scenario, and output, right? So I'm just telling a list of commands or list of actions that the agent is supposed to perform when this command is invoked, right? How it has to be performed is we are leaving it to the persona. We are leaving it to the LLM model to go to the persona, understand how these actions has to happen, and then perform the actions accordingly, right? So the inputs, whatever this agent takes, is either from the persistent memory or from the input that the user gives. There is no taking from previous chat or previous context. It always considers what is configured in the persistent memory or what the user is inputting, right? And again, output, as I mentioned, it will be in a labeled and structured format. You can define what label or what format you are expecting the output to be. That can be configured in the agent. And then each of the analysis that the agent does will be with evidence, like it will produce the evidence from where it has taken this decision or why it has taken a decision in a particular fashion, right? So in case if you want to backtrace in future to see how the assessment was done in this fashion, you can always go back and check. And this is another problem when we do a manual assessment, right? Because we are dealing with so many vulnerabilities, sometimes we miss the context as to why we assess the vulnerability as a false positive or a mitigate. So with this, you will have the backtrace available. Okay, so what is present in persistent memory? So basically, as I mentioned, this is a set of markdown files So it has one file for storing the CV dispositions, which is named as memories.md. As and when you do the assessment, there is an option to keep storing this assessment into this memories file. And we have another file called instructions.md, where we feed what are the disposition values that are available. Different organizations may have different kind of disposition guidelines and disposition values. So we can feed in as per our requirement. We can also say how a particular report has to be looked at. For example, you're passing a bill of materials, how it has to be treated, or if you're passing a scan report, how the report has to be understood. So those kind of information is present in these instructions. And then we have a product info, which stores details of the products. As I mentioned, the more information or more details you configure about your product, the better quality of assessments we get. Sorry. And the last one is the knowledge base, which has these disposition guidelines. So depending on our past experience, we have come up with some common use cases or common scenarios of vulnerabilities and how the assessment should happen in such cases. So we have a kind of table which we have generated. So we have fed in that table. Also, we have given a sequence of how the assessment should happen for a particular vulnerability. Right. So all these files can be easily shared with all the team. Let's say if I am doing a vulnerability assessment, I have built a precedent of, let's say, 100 vulnerabilities in my memories. When a new person joins the team, I can just share this information or share these details with that person. So when he uses this agent for doing an assessment, all these precedents will be stored, or he will get that advantage. Right. Every invocation of the agent will load this file freshly. It is not, as I mentioned, it will not depend on the chat history. So it loads the precedent every time when it comes up. Okay. So then we talk about what are the inputs that are expected for this agent. So this slide. At least couple of things here form the majority of the context awareness for this agent. So one is the product information, which as I said, you feed in your deployment models, your topology, your context, what OS it is running on, what are the default configurations you have enabled. Let's say by default you have multiple security features enabled. You feed in those kind of information, or you feed in the YAML file. Let's say you have a Helm chart. You feed in your override YAML file or the YAML file where all the default features are enabled. The agent will know, okay, because these features are enabled, maybe the vulnerability is not exploitable, right? So it will get that kind of information. And then you can feed in the scan report. It can be from in a CSV or a JSON format. We usually run Anchor and Trivy in some cases. So this feature also helps us because we don't have to worry about looking at individual vulnerabilities. We just pass in the whole report to the agent, and it takes care of doing the assessment. And then code base access. Yes, this is another important part. So here it can be your own code or Helm charts that you have developed, or if you're dealing with multiple open source components, it can be the GitHub link, or if you want to download the open source code and you want to maintain it yourself, you just pass in that location. So this will help the agent to traverse the code and see whether a particular function, let's say a function is vulnerable, if that function is invoked in a vulnerable way. So that kind of information can be fetched from the code access. Even if you don't pass the code access, it's fine. Just that the quality of assessment may be more generic rather than more specific to your code. Then we have the software bill of materials. So this is another important part. So here we feed in. We have multiple scan tools, right, to generate the bill of materials. We generate the bill of materials and pass it to the tool, so that this is kind of a first gate for the agent. So it first looks at this bill of materials to figure out whether we are really using that component and the version which is vulnerable, right? So that's why the bill of material becomes more important. Security test artifacts. Again, many of us might be doing penetration test. Many of us might be doing sys benchmark test. which will cover most commonly identified security issues, right? So if you're executing these tools, if you have a report, just feed in that report to the agent so that it knows what are the security tests that has happened. And then again, you can feed in your any documents that you have, HLD, LLD, or an architecture document. So this mainly is used for generating the attack scenario, as I mentioned, right? We want attack scenario to be generated. So these documents generally help in getting a better quality of attack scenario documentation. Okay, we'll talk a little bit more about the SBOM. So we support these models, SPDX, Cyclone DX, which is the most commonly used the bill of material formats. We also support CSV, and we also support plain text, just in case if you have RPM deployment, you just generate the RPM-QA, which will give you the list of RPMs that are deployed and just feed into the tool. And the SBOM that we pass, it is recommended that if you have multiple deployment models, you feed in SBOM per deployment model, because there are very high chances that the bill of materials might be different for different deployment models, right? So in order to get a good quality of assessment for each deployment model, we recommend having separate bill of materials for each. And how does the agent treat this bill of materials? So as I said, it's a first gate. It will look through the bill of materials, figure out whether the vulnerable package and the version is available in our bill of materials. If it is not available, it gets a very high confidence that it's a false positive. There are some additional checks that it does internally, but at least the confidence level is very high, saying it might be a false positive. And in case if it is present, then it proceeds with the further analysis to look at the code base and other information that has been passed, and then decide on the mitigation. In case if you don't have a bill of materials, you are not passing it, it is still okay, but just that the assessment might be a little bit more generic, or depending on what the feedback we have got from the community. Okay. Yeah, I'll quickly go through the default sources that I was that we have configured in the in the agent. So we have NVD, which is the National Vulnerability Database. So this is the primary source. Along with this, we are also using a source called OSV, which is Open Source Vulnerability Database. What we have seen is OSV has more recent updates and more context aware or ecosystem aware advisories that we get. And we also refer to GitHub advisories and Red Hat security updates, mainly for the OS packages. And then we have CV details for the CV statistics and historical context. So these are high level 4 or 5 sources that we have configured by default. Along with that, we also have this Maitri attack website, which has references for the attack scenario generation, and first CVSS for the CVSS score calculation. And this is the decision tree. Again, this is a very simplified model. There are multiple complications involved within each of these, but just for the sake of simplicity, I have captured a very high level decision tree that we have. So as and when the CV is received, the agent looks for the component in the SBOM. If it is not present, or if the version is not in the affected range, it thinks it as a false positive. If it is present, then it looks for further, does further inspection, and if a fix is available in the community, it decides it as mitigate and looks for mitigations or workaround until a fix is delivered. There are many cases where we have open source vulnerabilities, but community takes time to fix it, so there is no fix available. So in such cases, depending on multiple conditions, we either use mitigate with a flag waiting on solution, or we decide to accept the vulnerability, right? So again, there are multiple things involved within each of this box, but this is a very high level picture. The next couple of slides, I just captured a sample output of how the tool generates the assessment. So this is one of the old vulnerability which I have used. So basically, it's a vulnerability on a HTTP2 protocol, which eventually leads to denial of service attacks. So how the agent has decided whether it is applicable or not. It has gone through the bill of materials for the, by the way, this assessment is done for one of the database component, and we have both container and RPM deployments for this. So the agent has decided that it is applicable for container deployment, but not for the RPM and bare metal deployments. And the evidence for that is mainly coming from the SBOM, where in the container deployment we had ingress proxy, whereas on the RPM side, because we are exposing only the TCP port, we don't have a ingress reverse proxy as such. So that is the reason it is considering RPM as a false positive. And what is the rationale? It has generated saying that for a container ingress, we have it's reachable by the network attacker. However, there is a rate limiting feature already enabled, which reduces the impact of this vulnerability. Right, so that is the reason. If you see here, community has reported the vulnerability as CVSS score as 7.5, whereas the expert CVSS comes down to medium, mainly because the availability impact has come down from high to low. Right, and it has also captured the attack scenario and reference from the attack from the MyTray website on this particular scenario. So this is a high level output. Again, this is only a summary. It generates the report in much more detailed format, which I cannot capture in this slide. So that's the reason I have put it a very high level summary. And this is another case where vulnerability was reported on a kernel package. It's the most recent one. I think many of us know. It's famously known as dirty frag vulnerability. Whenever this vulnerability get reported, if you're doing a manual assessment, or if an inexperienced person is doing an assessment, we think that okay, Red Hat is reporting it as high. It's a kernel vulnerability. It's applicable for all of us, right? But that may not be the case all the time, right? Because whenever you are delivering a containers, you are not packaging the kernel modules as part of the container. So for a kernel module, or even for the application RPMs, right, it's a false positive. So we had similar instances earlier. So we had precedents stored in the persistent memory for such cases. So it has drawn the reference from one of the old assessment and giving us an evidence saying that it's a false positive. Right, so this is the kind of benefit we get by storing vulnerabilities or storing the assessments for future references. And this is a sample output for a batch CSV, rather a set of vulnerabilities that we get from the tool. So at a very high level, it contains the expert CVSS, it contains disposition, it contains the rationale, and the evidence, but again the rationale and evidence I could not fit in this slide, so that's the reason I have not captured. So it's in a CSV format. You can fine tune the fields as per your requirement and get the CSV output. Right, what next for Garuda? So we are planning to integrate this with our vulnerability management system. So we have an internal management system where we get new vulnerabilities. So we plan to integrate this with the system so that we automatically get those new vulnerabilities, do the assessment, and then feed it back to the system. Right, we also want to integrate with our defect management system so that in case if new tickets are required, we can create automatically. And we want to fine tune the precedent or the persistent storage even more so that it can be shared across multiple teams within Nokia. And then we also want to build the capability of auto detecting the deployment model. So because anyway we are giving the code base access, we should be able to figure out what deployment models are available in the product. So we want to kind of enhance that as well. And then I'm just sharing a list of references that we have. So yeah, you can go through this for more information. Yeah, that's all I had. Yeah, we can meet after the session for questions. And I would like to thank Michael and the ASA community and Nokia volunteers for giving me the opportunity. Thank you.